Hello friends, this video on equilibrium part 21 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's talk about the new effect where we have effect of inert gas addition. So effect of inert gas addition. If the inert gas is not reacting with the system, then there are two possibilities. If the volume is constant, there should not be any impact, because the volume is constant. If you see, there is no impact. Even if the pressure increases, the partial pressure will remain same proportionally. But if the pressure is constant, the volume is increasing. In that case, if the volume increased, we have the same concept. If the volume increased, the reaction moves to the side which has more number of moles. If the volume decreased, reaction moves to the side which has less number of moles. So we have N2. This example we have, let's suppose we have 2 moles here, we have 4 moles here. So if it is a constant pressure, the volume is increased, it will move in this direction with more number of moles. And also the second case is, if this inert gas react with the reactant or the product, then in that case this scenario is nothing but the scenario of change of concentration. So then in that case we can apply the formulas or the logic we have learned just few slides before, where we have told that if you increase or decrease the reactants of product, how the system will behave. Correct? Let's talk about the effect of temperature change. So if you change, see, till now we have been changing QC, but this temperature change impacts KC. As I told, when you have to give the value of KC, you should give the reaction plus temperature change also. Temperature also, right? So KC is defined at a given temperature. So you change temperature, the KC is changed. So when you change the temperature, the equilibrium constant itself change, and thus the equilibrium moves accordingly. And please note once again that QC is not changed in this case, only KC is changed. So where the equilibrium moves in case of temperature change? So it depends on the reaction. If it is exothermic reaction, that is delta H is negative, this equilibrium constant decreases as temperature increases. For a endothermic reaction, the equilibrium constant increases if we increase the temperature. See, logically also it makes sense. For example, I have reaction A plus B gives C plus D plus heat. Let's suppose this is an exothermic reaction. Now, since it is already given heat, if I am increasing the temperature, what will happen here? Since this part I had heat, so what will happen? The reaction will move in such direction that the temperature will decrease. So I am increasing the temperature, reaction will move in such a direction that the temperature will decrease. To decrease the temperature, the reaction has to go in this direction. Right? That is the case, the Kc has to decrease. Correct? Because if Kc is increasing, that means you are saying that reaction is going more forward. If Kc is decreasing, you are saying that reaction is going more backward. Similarly, for an endothermic reaction, you have AB, you give heat, then you get C plus D. So in that case, if you increase temperature, system will move in this direction to reduce the stress of the heat, so that the Kc will increase. Correct? Let's take an experiment on the temperature change. So you must have seen in the lab NO2 and N2O4. So NO2 is dark and N2O4 is light, right? And this is how it behaves. This NO2 at low temperature moves to this guy. You can say here is, and this guy N2O4 moves back to NO2 at high temperature. This is how the reaction happens, right? So N2O4, you give high temperature, it becomes NO2. NO2 you give low temperature, it becomes N2O4. This is what happens as per temperature change. So for this, what they had done in the lab, in the beaker we have water at room temperature. This is my sealed test tube which has both NO2 and N2O. So I have N2O4 and NO2, both are in equilibrium in this test tube. This is my test tube. This is my test tube. I'll write like this. This is my test tube. Sealed test tube, which has N2O4 also and NO2 also. Right? Now they are in room temperature, so they have color something like this. The moment I take this to a hot water, this hot water. The moment I take this hot water, what happens is, in high temperature, it moves towards NO2 side. So N2O4 in this, from here only, converts into NO2, and NO2 is what? Dark in color. So if you see, this becomes darker. Similarly, the same, the room temperature one test tube I took it here, and another test tube I'll take it here. And this test tube I keep in the ice, very cold. So cold, what happens? NO2, whatever was here, becomes N2O4, and N2O4 is light. So the color of this becomes light, right? So you had two test tubes which had N2O and N2O4 mixture in the equilibrium. The moment you shift that test tube to increase the temperature, that becomes darker because NO2 is formed. And if you cool that same system, it becomes lighter because in low temperature N2O4 is formed. So thus we can say that the change in temperature impacts the equilibrium. Just one experiment to prove this, that the change in temperature also impact the equilibrium. Okay. This reaction, if you want, you can write something like this: N2O4 plus little heat is thus N2O4. If I have the mixture, if I have, the moment I provide more heat, you get more NO2s, that is red. You decrease the temperature, equilibrium shift in this direction, you get more N2O4, that is light blue color. Correct? Let's take one example. What will happen to equilibrium when the temperature of the system is decreased? So if you see in this case, delta H is positive. That is, this is endothermic reaction. Correct? So you can rewrite this equation as to make my life simple. This plus heat is required to give N. Correct? So now, if you increase the temperature, what will happen? The reaction will move in this direction. But now, it says the temperature is decreased. So if you decrease the temperature, the reaction will move in this direction to counter effect the heat change. Correct? So it will move in the backward direction. Let's understand the effect of catalyst. See, catalyst, what happens is, it will increase the rate of reaction. And how it increases the rate of reaction? Because it forms some intermediate product which increases the rate of reaction, and again it gives the product back to the system. There's a whole logic behind that. So it increases the rate of reaction by increasing the rate of forward and backward reaction both equally. So, but it won't impact the equilibrium. It will not have any impact. And if you see, it will do nothing but it will increase the rate of reaction, chemical reaction, by providing a new pathway to reach that. For example, I'll tell you. For example, you have to reach from A point to B point. Let's suppose A to B. The normal route you have is this route, and this is 10 meter route. Okay, and your speed is 10 meter per minute or 10 meter per second. 10 meter per second. How much time you will take to reach from A to B? Obviously 1 second. Now what this catalyst will do, instead of giving that route, catalyst will give you this route, and this route is 1 meter. So if your speed is 7 meter per second, this guy will take 1 second and this guy will take 0.1 second. Which one is faster? Obviously this. So catalyst will do nothing but it will give you alternate way to reach from point A to point B very fast, but will also give a route to reach from point B to A also very fast. So both forward and backward reaction has increased equally. So there is no change in the equilibrium, right? But note that if the K is very small, even if you add a lot of catalyst, it won't increase the reaction that much. K should have some value. Then only catalyst will help you. We'll do some recap on this. Please pay attention here. So we have some different kind of stress we had was something like increase the reactants, increase the product concentration, increase the temperature, decrease temperature, increase pressure, decrease pressure, add catalyst, add inert gas at constant volume, add inert gas at constant pressure. All this stress we learned. So let's talk about the direction of equilibrium. So increase the concentration of reactant, it moves in the forward direction we have seen because we have A plus B gives C plus D. So if you increase the reactant, it moves in the forward direction, right? If you increase the product, it moves in the backward direction, correct? You increase the temperature, if it's an endothermic reaction, it moves towards endothermic reaction. If you decrease the temperature, it moves towards exothermic reaction. This thing we explain. You increase the pressure, it moves towards lesser number of moles. That also we explain. You decrease the pressure, it moves towards more number of moles. Addition of catalyst, no effect. You add inert gas at constant volume, no effect. Constant pressure, there is effect. If you towards larger number of molecules, if the volume is increasing, right? Now let's talk about Kp and Kc and Kp change also. We'll see this impact Kp or Kc. So increase the concentration, Kp and Kc will not have any change. Decrease the concentration of product, no change. Increase temperature, Kp will have a change. Please note Kp and Kc will have change only when you change temperature. You increase pressure, decrease pressure, add catalyst, you add inert gas, the Kp and Kc value will not change. Kp and Kc value will change only when you play with temperature. Correct. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.